Are you fed up with having to comb through countless search results to locate the information you require? What if I told you that there is a cutting-edge technology available that allows you to get precise answers to your inquiries right away? Envision a world in which you have easy access to information that is customized to meet your requirements. We demonstrate the revolutionary potential of artificial intelligence in question-answering systems in this video. How does artificial intelligence understand language used by humans? What methods does it use to accurately retrieve pertinent information? Come along as we examine 10 amazing ways that artificial intelligence is changing the question-answering world. Watch now to see how artificial intelligence is transforming information retrieval. 1. Semantic Understanding. Artificial intelligence-driven question-answering systems are based on semantic comprehension, which is a major divergence from conventional techniques. By utilizing the complex network of natural language processing (NLP) methods, artificial intelligence systems are now able to comprehend human language and go beyond simple keyword matching. By utilizing sophisticated algorithms and deep learning models, these systems examine the subtleties of language context and interpret not just what is spoken, but also what is intended. Artificial intelligence can give more relevant and accurate answers that are suited to the needs of the user by understanding the intent, semantics, and implicit meanings of user queries. A new era of effective information retrieval is being ushered in by question-answering systems' ability to bridge the gap between human language and machine understanding thanks to this semantic comprehension. 2. Machine learning algorithms. Modern Q&A systems are built on top of machine learning algorithms, which enable them to continuously adapt and get better. These algorithms allow question-answering computers to learn from massive volumes of data and derive relevant insights. They range from conventional statistical methods to state-of-the-art deep learning techniques. Support vector machines, SVM, and decision trees are two examples of supervised learning techniques that are used to classify and categorize textual input in order to provide precise answers to user queries. In the meantime, the system's comprehension and arrangement of data are improved using unsupervised learning algorithms, such as clustering and dimensionality reduction approaches, which assist in revealing hidden patterns and structures within the data. In addition, question-answering systems can communicate with their surroundings through the use of reinforcement learning algorithms. By getting feedback on the correctness and relevancy of their responses, these systems can improve their performance over time. Question-answering systems can continually change and adapt to match the ever-changing needs of users by utilizing machine learning, resulting in a smooth and effective information retrieval experience. 3. Natural language processing (NLP). The ability of artificial intelligence-driven question-answering systems to comprehend and interpret human language in its natural form is made possible by natural language processing, or NLP. NLP techniques cover a broad range of approaches from semantic understanding to syntactic analysis, all with the goal of obtaining meaning from textual data. NLP's fundamental tasks include parsing sentences, recognizing speech components, and examining language's grammatical structure. Q&A systems can discern the intent and context of user queries thanks to this fundamental understanding, which enables more precise responses. Furthermore, NLP methods like sentiment analysis and name entity recognition (NER) improve the system's capacity to extract pertinent data and offer responses that are appropriate for the given context. NLP has advanced significantly with the introduction of deep learning models such as transformers and recurrent neural networks (RNNs), which allow question-answering systems to understand and capture the finer points of human speech with previously unheard-of precision and efficiency. Consequently, natural language processing (NLP) is essential for bridging the gap between human language and machine understanding, which propels the development of more natural and intuitive interactions for question-answering systems. 4. Named entity recognition (NER). Named entity recognition (NER) is an essential part of artificial intelligence-driven Q&A systems that improves the system's capacity to precisely locate and classify items in textual material. Entities are particular categories of things or ideas, such names of individuals, groups, places, dates, and numbers. Text is analyzed by NER algorithms to identify and categorize these items, allowing Q&A systems to get pertinent data and deliver responses that are appropriate for the given context. 3. Identification of entities. NER enables a more thorough comprehension of the underlying information, enabling the system to provide more accurate and insightful responses to user inquiries. In addition, NER is essential for a number of uses other than answering questions, such as information retrieval, document summarization, and sentiment analysis. Question-answering systems may now extract important insights from textual material with greater accuracy and efficacy thanks to the ongoing evolution of natural language processing (NER) and machine learning techniques. 5. Contextual Understanding. A key component of artificial intelligence-driven Q and its systems is contextual understanding, which helps them to comprehend the context of user inquiries and deliver more pertinent and accurate answers. Contextual understanding approaches use sophisticated algorithms and models to assess the larger context in which words and phrases are used, in contrast to standard keyword-based approaches that frequently fall short of capturing the nuances of language. The creation of language models such as BERT, bidirectional encoder representations from transformers, which are trained on enormous volumes of text data to comprehend the contextual links between words and sentences, is a significant breakthrough in this field. Question-answering systems can better understand the meaning and intent of queries by taking into account the surrounding context, which results in more accurate and instructive responses. With the help of this contextual understanding, the systems are better equipped to handle complicated or ambiguous inquiries and give consumers the information they require in a way that feels more natural and intuitive. Further developments in contextual understanding approaches could improve Q and a system's capabilities and make them even more proficient at reading and responding to a broad variety of user queries as artificial intelligence progresses. 6. Knowledge graph integration. An important development in artificial intelligence-driven Q and a systems is knowledge graph integration, which transforms how well these systems can access and apply structured knowledge. Knowledge graphs are organized depictions of data that show the links between concepts and things. They usually take the shape of connected nodes and edges. Artificial intelligence may make better sense of this abundance of structured data and respond to user inquiries with greater depth by incorporating knowledge graphs into Q and A systems. Question-answering systems can navigate links between items through knowledge graph integration, finding pertinent connections and insights that might not be obvious from separate pieces of information. Furthermore, knowledge graphs allow Q and A systems to integrate domain-specific knowledge, enabling customized, accurate, and contextually relevant responses. The incorporation of structured knowledge expands the scope and profundity of data that can be accessed by Q and A systems, enabling them to provide more complex and perceptive responses to a variety of inquiries. Integration of knowledge graph technology into Q and A systems has the potential to unleash even higher levels of comprehension and intelligence, revolutionizing information access and interaction as it develops. 7. MultiTurn dialogue systems. A major development in artificial intelligence-driven question answering is multi-turn dialogue systems, which enable more conversational and natural interactions between humans and robots. Multi-turn dialogue systems preserve context across numerous exchanges, enabling a conversation-like interaction flow in contrast to standard single-turn systems that offer isolated responses to individual requests. Sophisticated dialogue management algorithms and approaches are used to accomplish this, allowing the system to recall previous encounters, predict human intent, and respond coherently throughout a conversation. Engaging and productive discussions can result from multi-turn dialogue systems' ability to address complex queries that span numerous topics or require iterative explanation. The user experience can also be improved by these systems' ability to gradually adjust to changing user preferences and behaviors. Multi-turn dialogue systems transform question answering, making it more accessible, effective, and user-friendly than ever before by facilitating fluid and intuitive interactions. 8. Deep learning architectures. Artificial intelligence-driven question-answering systems have undergone a paradigm change thanks to deep learning architectures, which have completely changed how these systems can comprehend and handle complicated textual input. Deep learning architectures can extract complex patterns and representations from enormous volumes of data by utilizing neural network models with numerous layers. This allows for more precise and nuanced responses to user inquiries. While recurrent neural networks, RNNs, are better at modeling sequential dependencies, convolutional neural networks, CNNs, are better at capturing spatial patterns in text. This makes RNNs a great choice for jobs involving natural language processing. Recently, transformer-based architectures have become the state-of-the-art. Models like BERT, bidirectional encoder representations from transformers, have achieved unprecedented performance in answering questions by utilizing self-attention mechanisms to capture long-range dependencies in text. With the ability to understand and reply to human language with astounding accuracy and fluency, these deep learning architectures have revolutionized the field of question answering and opened the door for more sophisticated and interactive information retrieval systems. 9. Domain-specific customization. Optimizing artificial intelligence-driven Q and A systems for diverse sectors and fields requires domain-specific modification to guarantee precise, pertinent, and customized responses that address the unique requirements and obstacles of a given domain. Through model optimization, integration of domain-specific datasets, and integration of specialist vocabulary and terminology, These systems are able to provide users within their respective areas with accurate and meaningful insights that improve decision-making, productivity, and user happiness. Question-answering systems that are tailored to a particular domain can match the specific information needs and expectations of users in a variety of fields, including healthcare, legal research, financial analysis, and others. This promotes efficiency and creativity in these sectors. 10. Feedback mechanisms. Artificial intelligence-driven Q&A systems have evolved significantly thanks to feedback mechanisms, which enable ongoing optimization and enhancement depending on user interactions. Question-answering systems can learn and adapt iteratively, improving with time, thanks to processes that gather input on the correctness and relevancy of responses. These processes, which can be triggered by explicit user feedback or implicit cues like user behavior and engagement, offer important insights into how well the system responds to user input and enable focused optimizations and modifications. In addition, feedback methods help users and the system work together more closely, giving users the ability to enhance the system and make sure their information demands are more efficiently satisfied. Because of this, Q&A systems can develop to better serve users by providing more precise, pertinent, and fulfilling answers in a constantly shifting and dynamic information environment. Subscribe now and unlock the secrets of artificial intelligence-driven question answering and stay ahead in the world of information retrieval.